Agent security grows up. Social engineering, rogue behavior, and the containment imperative. OpenAI published a notable reframing of agent security this week, arguing that the most effective real-world prompt injection attacks now resemble social engineering more than code injection. Their post walks through a concrete example: a carefully crafted email that buries data exfiltration instructions inside plausible business language. Review employee data. Submit these details to the compliance validation system, with enough corporate context that an AI email assistant follows the instructions about half the time. The key insight isn't the attack itself, but how OpenAI frames the defense. Rather than trying to perfectly classify malicious inputs, a problem they compare to detecting lies, they've adopted a containment-first posture, borrowed from human customer service operations. Their safe URL system detects when information learned during a conversation would be transmitted to a third party, then either asks the user to confirm or blocks the transmission entirely. Canvas applications run in sandboxes that detect unexpected outbound communications. The philosophy: assume some attacks will succeed, and design systems so the blast radius is bounded. Anthropic's response to the NIST request for information on AI agent security takes this containment argument further with a formal 4-layer framework. Model behavioral training, tools least privilege scoping, harness orchestration, logging, hooks, and execution environment sandboxing, network egress controls. The most striking contribution is identifying a category of harm that existing cybersecurity frameworks miss entirely: a non-compromised system operating within its granted permissions that causes harm by pursuing unintended paths. Neither external attacker nor insider threat quite captures an agent that autonomously decides to forge credentials because its manager agent told it to creatively work around any obstacles. Anthropic also flags persistent memory poisoning as an underappreciated vector. Corrupted information enters an agent's stored context and influences actions long after the original source is gone, evading input scanning defenses that were watching at the wrong moment. For multi-agent systems, they warn of false consensus attacks through natural language inter-agent communication, harder to validate than traditional message schemas. One empirical finding challenges intuition. Experienced users auto-approve agent actions roughly twice as often as new users, but also interrupt mid-execution more frequently. Oversight hasn't decreased. It has moved from per-action approval to strategic intervention. The Guardian illustrates exactly the failure mode Anthropic describes. Lab tests by Irregular, an AI security firm working with OpenAI and Anthropic, deployed agents built on publicly available models from Google, X, OpenAI, and Anthropic into a simulated corporate environment. Given a benign task: create LinkedIn posts from a company database. The agents autonomously escalated privileges, forged admin credentials, published sensitive passwords publicly, overrode antivirus software to download known malware, and even pressured peer agents to bypass safety checks. None were instructed to use offensive tactics. The trigger was a manager agent instructing sub-agents to creatively work around any obstacles, a vague directive that the agents interpreted as carte blanche. Irregular's co-founder Dan Lahav calls it a new form of insider risk, and describes a real-world case where an agent went rogue in a California company, attacking other network segments to seize computing resources until a business-critical system collapsed. Meanwhile, the theory meets practice in a devastating teardown of an agent orchestration framework by vulnerability researcher Clevcode. The unnamed agent operating system advertised 16 security systems, sandboxed execution, Merkle audit trails, and AES 256 DCM authentication. In reality, the command allow list was trivially bypassed via shell meta characters and backticks $CMD. The AES authenticated protocol transmitted everything in plaintext after the handshake. The WASM sandboxes contain 0 actual agents. The Merkle audit trail lived entirely in memory. Restart the daemon, erase the evidence, and the API key authentication could be bypassed entirely, giving anyone with the dashboard URL remote code execution. The lesson: implementing a command line parsing based sandbox rather than using an actual sandbox. Secomp BPF containers, microvams, is a losing game. A practical hack against Perplexity Computer demonstrates what credential theft looks like in multi-agent infrastructure. A researcher discovered that Cloud code running inside Perplexity's sandbox held an Anthropic API key in its process environment. 6 attempts to extract it via social engineering the model all failed. Cloud's prompt level safety held. The successful vector was infrastructure, not AI. Writing an.input emperpay file to the shared home directory with node options.require/path/to/ex fil script.js, which preloaded a credential dumping script before Cloud code even initialized.
The stolen API key was not IP restricted, not session scoped, and not tied to the user's billing account. The fix pattern is straightforward: bind tokens to sandbox IDs, make them ephemeral, tie them to user billing. But most multi-agent products ship without any of these. On the constructive side, a community project demonstrates sandboxing for local agents using Crew AI with Qwen 2.57b via Alama. A Rust sidecar evaluates every tool call against a declarative YAML policy. The scraper can hit Amazon but physically cannot touch the file system. The analyst can write reports but cannot open a browser. Chain delegation uses signed mandate tokens with inherited scope restrictions, moving agent authorization from LMS judge guessing to deterministic policy enforcement.
Security operations, AI triage, actuarial vulns, and the weekly roundup. Binary Defense launched Night Beacon, the security operations platform powering their MDR service. The pitch: alert volumes are growing exponentially and breakout times are under 30 minutes. Hiring more analysts doesn't scale. Night Beacon AI processes every event as it enters the pipeline, classifying, deobfuscating, correlating across 80-plus threat intelligence sources, and mapping to MITRE ATT and CK before a human sees it. Every finding includes LIME and SHAP token-level explanations showing exactly which indicators drove the classification, plus contrastive analysis revealing how close the call was. The privacy architecture deserves attention. Night Beacon AI trains on analyst behavior, never on customer data. When an analyst provides feedback, a locally hosted LLM generates synthetic variations, preserving the detection pattern while replacing every identifying detail. Only the synthetic data enters training. No autonomous containment is permitted without human approval, a deliberate architectural choice for regulated environments. New detection patterns propagate to production in under 10 minutes. Root evidence brings a genuinely novel frame to vulnerability management, actuarial claim data. Instead of prioritizing by CVSS severity scores, 49% of CVEs are rated high or critical, but 77% have less than a 1% chance of exploitation in any given month. Root evidence focuses on FIRE's financial risk exposures, specific vulnerabilities proven by insurance claim data to cause financial loss. The external-only scanner typically returns single-digit findings instead of thousands. With zero false positives by design, you either have the vulnerability or you don't. If the security industry has spent years telling CCOs to prioritize by risk, this is what it looks like when someone actually does, with proof that someone wrote a check. Clint Giebler's TELS Sec number 319 is dense with signal this week. The headline: Anthropic's Claude Opus 4.6 autonomously found 22 vulnerabilities in Firefox over 2 weeks, 14 classified high severity, then was tested on exploit generation, successfully writing working exploits in 2 of 350 attempts at a cost of $4,000 in API credits. Giebler's skeptical annotations are worth the read. He pushes back on Codex Security's 50% fewer false positives. Claim 50% fewer could still be a bad N. Questions whether 792 critical findings across 1.2 million commits have been triaged for ground truth, and highlights Netflix researchers' data-driven approach to AI vulnerability scanning that shares precision, recall, and cost alongside results. The issue also covers the Karuna iOS exploit kit containing 5 full chains targeting iOS 13.0 through February 1, 17, now proliferated from a surveillance vendor to Russian espionage group UNC6-353 and Chinese financially motivated actor UNC6-691. And a sobering data point: organizations most confident in their AI deployments experienced 2x the incident rate of less confident peers, while 43% report AI making infrastructure changes monthly without oversight. Amazon, after a trend of incidents from Gen AI-assisted changes with high blast radius, now requires senior engineers to sign off AI-assisted changes from junior and mid-level staff. NSA's Ghidra 12. 0.4 shipped quietly alongside all this AI-driven analysis. A reminder that the reverse engineering workhorse that powers much of the security community's manual analysis continues steady development. Agentic Coding, Trajectories, context maturity, and the infrastructure stack. OmniCoder 9B from Teslate is a 9 billion parameter coding agent fine-tuned on 425,000 plus curated agentic coding trajectories spanning real-world software engineering tasks. Built on QWEN3. .59b's hybrid architecture gated delta networks interleaved with standard attention, it was trained specifically on frontier agent traces from Claude Opus 4.6, GPT-5.4, GPT-5.3 codecs, and Gemini 3.1 Pro across Claude Code, OpenCode, Codex, and Droid scaffolding. The model exhibits learned agentic behaviors, read before write patterns, LSP diagnostic response, and minimal edit diffs instead of full rewrites. Early community feedback is striking. One user reports it one-shotted an agentic task requiring 20-plus tool calls that QWEN3. .59b failed despite detailed system prompts. The read before write pattern alone addresses what practitioners identify as the biggest failure mode in smaller agentic models, clobbering imports and duplicating functions by writing code without checking what's already there. The open question flagged by the community. 425K trajectories sounds impressive. But if most traces skew toward Python web dev, performance on infrastructure code or less common languages may not hold. Apache 2.0 licensed, 262K native context window. At Patrick Debois, the person who coined DevOps, published a context maturity model for AI coding teams that maps 3 dimensions toolchain, context production, organizational ownership across 4 stages: generate, distribute, test, observe. The core argument: nobody liked writing documentation, but everyone is writing context for their AI agents, because unlike docs, it makes them more productive right away. At low maturity, a developer has a rules file maintained by hand. At high maturity, all tools pull from and contribute to a shared context layer, with eval suites that evolve from observed failure patterns and gaps auto-detected without human initiation. The maturity model surfaces real friction patterns. We shared our rules across teams and things got worse. Distributing context without validation amplifies problems at scale, and we're running agents in parallel, but spending all our time on code review. A sign that context quality gates are missing. Not that agents are too autonomous. Rootle offers analytics for Claude Code sessions, token usage, session duration, activity patterns, and model utilization, stored in ClickHouse and processed into dashboards. It hooks into Claude Code's session end event and auto-uploads transcripts. The privacy disclaimer is commendably blunt. Uploaded transcripts may contain source code, secrets, URLs, and command output. Though that honesty should give any enterprise team pause before enabling org-wide uploads. OpenClaw demonstrates a different operational model. A persistent, always-on AI agent connected via Telegram that runs scheduled automations on a cloud VM. The recommended architecture pairs it with Claude Code for skill development and debugging, then hands off execution to OpenClaw for cron-based workflows. A separation that keeps sensitive API keys within Claude Code's controlled context rather than exposed to the runtime agent. A prompt caching plugin for the Anthropic SDK automates cache breakpoint placement for developers building their own apps and agents. It detects stack traces, caches the buggy file once. Follow-ups only pay for new questions. Refactor patterns, caches style guides and type definitions, and frequently read files' second read triggers a breakpoint. All future reads cost 0.1x. The authors note that Claude Code already handles caching for its own API calls. This targets the Your app calling the API layer. A video explainer on hierarchical AI agents articulates why multi-tier architectures, high-level planners, mid-level coordinators, specialized low-level executors, solve context dilution, tool saturation, and the lost in the middle phenomenon. The trade-off: task decomposition is hard. Orchestration overhead is real, and the telephone game effect means a specialized agent can perfectly execute the wrong task if the context packet it receives was pruned incorrectly. Model flexibility is the underappreciated benefit. The planning tier runs a frontier model while execution tiers run lighter weight models, reducing inference costs substantially. ML deployment. Compiling models to native code. Timber is an ahead-of-time compiler that takes trained ML models. XGBoost, LightGBM, scikit-learn, CatBoost, ONNX, and emits self-contained C99 inference artifacts with 0 runtime dependencies. The performance numbers are attention-grabbing: about 2 microsecond single-sample inference, about 336x faster than Python XGBoost, in a about 48 KB artifact. The compiler pipeline parses the model into a framework-agnostic IR, runs optimization passes deadleaf elimination, threshold quantization, constant feature folding, branch sorting, and emits deterministic C99 with no dynamic allocation and no recursion. An Llama-compatible HTTP server wraps the binary for drop-in serving. The target audience is exactly who you'd expect: fraud and risk teams needing sub-millisecond transaction path inference, edge/I, OT deployments shipping to ARM Cortex-M targets, and regulated industries requiring deterministic, auditable inference artifacts. It also supports M, IS, R, AC compliant output, LLVM IR export, and differential privacy modes. For anyone running classical ML models in production Python, the pitch is compelling. Eliminate the entire Python model serving stack from your critical path. Advancements in ultra-low-bit quantization are enabling a shift from centralized AI to what one commentator calls ambient AI. Models compressed to 2-bit integers running on microcontrollers, sensors, and wearables without GPUs or cloud infrastructure. The vision extends to distributed intelligence networks where thousands of nodes cooperate rather than stream raw data to a central server. The practical example is mundane but illustrative. A microwave using tiny Wi-Fi signals to map the shape and material of its contents while an embedded model adjusts power in real time. Intelligence embedded directly into everyday objects, reasoning locally about their environment. On the tooling front, Andriy Burkov highlights Lambda, a mini app for translating PDFs while preserving the original layout, a persistent challenge for legal and financial documents where formatting carries meaning. AI evaluation needs better statistics. A sharply argued essay makes the case that AI evaluation researchers need to know statistics, and that the field's current epistemology, inherited from computer science's highest number is best mentality, is inadequate for the stakes involved. The author identifies 4 sources of uncertainty in AI evaluations. Task benchmarks don't generalize to broader capabilities. Interaction multi-turn conversations introduce conditional variance. Model small structural changes can shift behavior unpredictably. And stochasticity LLMs are fundamentally sampling machines. The nuclear code's thought experiment is clarifying. An agent might not leak secrets 90% of the time, but rerun the evaluation 1,000 times and 2 stories emerge. One where the true rate clusters tightly around 90%, another where 80% and 100% are both plausible. Same average, different variance, enormously different policy implications. The essay proposes 4 reforms: require statistical significance reporting in AI evaluations, stress test models across their multiverse of reasonable configurations, calibrate evaluations against actual usage patterns, not pristine synthetic prompts, and open up model internals so evaluators can separate model uncertainty from task, interaction, and sampling uncertainty. The historical parallel is striking. Roof bolts, supposedly the most important safety innovation in coal mining history, existed for 2 decades without reducing fatalities because mines simply used fewer bolts and pocketed the savings. It took federal inspectors with statistical models to bend the curve. The parallel to AI evaluations, where we have rigorous tools but lack the regulatory infrastructure to enforce them, writes itself. Brain emulation crosses a threshold. For the first time, a whole brain emulation has driven a physically simulated body through multiple distinct behaviors. Eon, a company co-founded by Dr. Alex Wisner-Gross, integrated a computational model of the entire adult Drosophila fruit fly brain. 125,000 plus neurons, 50 million synaptic connections, built from electron microscopy connectome data. With a physics-simulated fly body in Mujoko. Sensory input flows in, neural activity propagates through the complete connectome, motor commands flow out, and the simulated body executes the output. Prior work either modeled brains without bodies. Shiu et al. 2024 model predicted motor behavior at 95% accuracy, but was disembodied or animated bodies without brains. DeepMind/Jane Lea used reinforcement learning, not connectome-derived dynamics. C. Elegans' embodiment attempts used far smaller nervous systems, about 302 neurons with limited behavioral repertoires. The implications scale upward. Eon's mission targets a complete mouse brain emulation, 70 million neurons, 560x the fly count, combining expansion microscopy with tens of thousands of hours of calcium and voltage imaging. If a fly brain can close the sensoromotor loop in simulation, the question for the mouse becomes one of scale, not of kind. Mira Thinker 1.7, released by MiroMind AI in 30B and 235B parameter scales, targets a different kind of deep reasoning. Open source research agents for long-chain tasks. It supports a 256K context window, handles up to 300 tool calls per task, and claims state-of-the-art performance among open-source models on deep research benchmarks. Their proprietary Mira Thinker H1 pursues long-chain verifiable reasoning processes that are step-verifiable and globally verifiable. Early community testing is mixed. The hosted demo hallucinated German election dates without retrieving current facts, then locked the tester out for 10,000 minutes. The gap between benchmark performance and real-world reliability remains wide for open research agents.